In quantum repeaters, our next topic is how the applications are security, how we will provide the security for quantum networks, how we will provide the security for the quantum networks. Here we have majorly using the three formats for providing the security for quantum network. One is unconditional secure network, and second is the quantum secure network, and third one is the distributed quantum secure network. In quantum secure network, we will make the use of QKD algorithm and multi-party computation network. Multi-party computation network, we will provide the security for quantum networks which will be protected from the attackers. We will make the use of in unconditional secure communications network. We will make the use of QKD and multi-party computation network security. By using this technology, we will provide the security for our quantum network. In quantum secure quantum computing, we will provide we will provide the blind quantum computing. We will provide the blind quantum computing. Let us outsource without losing or exposing your data. In secure cloud computing in quantum, we will not expose our data to others. We will encrypt the totally, we will encrypt the data in the quantum bits, and we will not expose our data or results without revealing any inputs. We will use the algorithm called QKD and POC algorithms. And next one is the distributed quantum sensing. In distributed quantum sensing, we will use of network sensors. We will in sensing network, we will use of the sensors for detecting the threats. Whatever the threats we will present in the quantum network, we will identify with the help of the network sensors, which are very highly sensitive, very highly sensitivity, which has the sensors are ultra high sensitive sensors. We will use the high ultra sensitive security sensors for identifying the any errors or bugs in our network. And next concept is how we are securing the in critical infrastructure. We are mainly using it is in a power grid systems and water treatment, transport and traffic systems, and financial marketing and healthcare networks. We are mainly using our quantum in power grids and water treatment plants, transport and traffic systems, financial marketing, and healthcare system. For that, we should have to protect the all the vulnerabilities from the system. We should not allow the attackers to attack our system. We should have to be very planned algorithm. We should have to plan the algorithm accordingly to protect the attacker. This system will require both security and as well as a protection. We should have to provide the guarantee for the all the systems. Why? Because everyone is an try to steal the data or from the systems. We should have to protect the data very confidently in power grid and water treatment and transportation, mainly in financial transaction. Mainly in financial transaction, we should have to not only provide the security, we should have to provide the long back protection guarantee. We can align with this, we can achieve with the help of with the help of the quantum capabilities. Example, a quantum secured smart grid can detect and prevent the cyber attacks early before they able to attack. With the help of the all these algorithms, we previously discussed three algorithms, a quantum secured smart grid can detect and prevent the cyber attackers before they attack itself. Before they are planning to attack, it will identify the system with the help of these three security layers. One is unconditional secure communication and secure cloud computing and sensing sensors. With the help of the sensors and secure cloud computing and secure communication, it will protect the all the infrastructure before the attackers are going to attack our systems. And majorly our quantum computing is used in the major smart cities. With the help of the quantum network, we are developing the each country as a smart city. Why? Because everyone is becoming the automation. Every device is becoming a automation. It should has to operate itself. Example, Tesla car. The Tesla car can be having an autopilot mode. It will work without any driver, and it will securely reach our destination, which will provide the security for the car and the participant. Here we have the three types of smart quantum secure smart cities. One is device authentication, and second is the secure autonomous systems. Next one is privacy protection. Here device authentication is nothing but we should has to prevent the spoofing of IoT systems. Everywhere we are using the IoT sensor, it should not be spoofed. Why? Because if they are spoofed, they can able to develop the another IoT sensor which with the help of same one. They can develop the applications, or they can develop the devices. So we should have to provide the huge security for that device with the help of the authentication. We should provide the authentication for the all the devices for spoofing. Why? Because the man in the middleman, it is nothing but the attackers will attack the sensor and all take the all the controls from the system. Next one is secured autonomous system. We should have to protect. It is nothing but we are using in Tesla car as an autopilot mode. We should have to protect the driverless cars and emergency systems. We should provide in emergency system. We should have to provide it. Next one is privacy protection. Privacy is a very crucial role in every network. Why? Because we should have to maintain the privacy. It should not be data leakage. We should have to safeguard the citizens' data, whichever or what data we have collected via urban IoTs. Everywhere we have collecting the data of the customers. It should be a very priority wise. We should have to store the all the data and safeguard. It should be an encrypted model. It should be not be decrypted. Why? Because if they can able to decrypt, everyone can able to access the data. So we should have to provide the privacy for the customers. Next one is the challenges in implementation. There are a lot of challenges. Among them, one is technical hurdles. Technical hurdles is nothing but we should have to maintain the particular room temperature for quantum systems. It is nothing but we should have to maintain the reliable room temperature for quantum memories. We should always maintain the temperature. The system should be also in the temperature of the space temperature or below 0 degrees Celsius. We should have to maintain the system in very cool temperature. Why? Because we are using the n number of transistors in the system. It will generate the lots of heat. To provide the heat protection, we should have to maintain the temperature cool. Next one is the large scale of error connection. If there is any error, if there is a large error connection, it is possible for large errors. Next one is multiplexing channels. There is a large number of entanglement with the swapping. For that, we should have to provide the multiplexing channels. Next one is the deployment. For the deployment of the quantum computers, it is high cost of the hardware. To prepare the hardware, a major thing is we require the cooling system. For cooling purpose, we should have to maintain the chillers. And next one is the chips are made up of the gold foils. It is not a silicon one, no. So that's why we should, its cost is very high when compared to our classical system. Next one is integration of the network. We can't able to integrate the our existing system with our quantum computer. Why? Because the classical computer is a different from the quantum computer. We should, if the integration is an easy, the cost can be reduced. Why? Because the cost is very high when compared to the classical system and quantum system. Next one is workforce. There is a very skill gap between the workflow. Why? Because in quantum computing, we are mainly using the physics concept. It is nothing but the quantum physics. It is not a theoretical or a practical one. With the help of the physical logics, we will develop the system. Next one is the standardizing. Here we have some standard errors for the quantum. It's one is nothing is IETF. One is IETF. It is a quantum inter research group. And next one is ITU. Next one is ETSI. Next one is ISO IEC standards. These standards are provide the security for all the architecture or system infrastructure. They provide the few standards for our system, but it is very standardization effort to maintain these workflow. You should has to maintain all this IETF, ITUT, ETSI, and ISO EC, and roadmap for the deployment. This is the roadmap for the deployment. USA Quantum Internet Base, and there are total 70 node of network. One is Akron, one is Primlip, Chicago, in Chicago and in New York. All these are expanding their quantum computing in this with the help of 17 nodes. In USA is expanding their quantum technology, and most of the pan Europe countries are using the quantum internet. And next one is the China. China is the one of the backbone for the quantum because it has launched the Mesius satellite. It can be able to communicate with a range of 2000 kilometers between the Beijing and Shanghai. Linked with it, this have the trusted node, and there is the no repeaters. Without repeaters, it can be able to communicate between the range of an 2000 plus kilometers, and it has been very secure. There is no repeater. If there is a repeater, it can able to transmit the data more than 2000 plus kilometers. Without repeaters only, it is transmitting the 2000 plus kilometers. And the future timeline. Implementation time is taken from 2023 to 2025. It was the first one to 2022 pilot repeater network. It has a nodes of 5 to 10 nodes. In 2023 to 2025, they made the repeaters of network like 5 to 10 nodes. And in 2026 to 2030, there will be a regional network. It should be covered with the regions, and it should have minimum 20 to 50 nodes. By 2030 to 35, it will be a national network. It will be a national wide. It should has an 100 plus nodes. By 2040, it has a global quantum internet. They want to quantum in globally. They want to establish the quantum internet throughout the globally within the time period of 2040. Organization should plan now, and they are too long risk falling for our blind. Why? Because with the help of these technologies, they can able to access our classical system very easily. So we should have to face the consequences after 2040. And security and planning recommendations. Here one is an established strategy. Here established strategy is nothing but we should have to create a roadmap for creating the quantum security integration between our system, our classical system, and we should have to communicate with the quantum system also to provide the communication between the quantum system and provide the communication between our classical system. We should have to ready with our strategy, quantum strategy. Why? Because we should have to communicate with the normal system and quantum system. Next one is an infrastructure assessment. It is nothing but we should have to provide the fiber networks and repeaters feasibility. With the help of the repeaters, we should have can be able to communicate with the large range. Next one, partnership and pilots. Collaborate with the quantum test based. We should have to collaborate with the quantum test based and research institutions like in USA, USA, China, and European countries. Many European countries are working on the quantum. We should have to make the partnership with the quantum leaders globally. Has China, we should have to make the partnership with them. Then we can able to acquire the quantum networks to other countries also. Next one is the security skill development. We should have to train the security engineers in quantum info science. Why? Because now we are training all the engineers in the AI mode, AI and machine learning, but upcoming one is the quantum. So we should have to train our junior engineers in quantum engineering. And key takeaways. These are the quantum repeaters are essential for extending the quantum technology. We should have to have the quantum repeaters are essential for scaling the behind the 100 kilometer to transfer the data above the 100 kilometers. We should have to use the quantum repeaters are essential. Next one is tech is an advising rapidly. Technology is